Good afternoon, everyone, and welcome to the IMTS conference. I'm Elizabeth Modick, editor of GIE Media's manufacturing group of magazines, Today's Medical Developments, Aerospace Manufacturing and Design, Today's Motor Vehicles, and Today's E-Mobility. If you have any questions during Jeff's presentation today, please feel free to type them into the Q&A section. You'll find that at the bottom of your screen, and we will get to answer as many of those questions as we can at the end of the presentation. Your presenter today is Jeff Wilkinson. He is the Director of Research and Development at the Starrett Company. His presentation is going to look at IoT and Industry 4.0 and the new paradigm in manufacturing. Increasing the speed, amount, and accuracy of data generation is a critical necessity. Jeff will provide a comprehensive look into the very latest technology that manufacturers can reliably use to economically meet and exceed even the most challenging demands of today's quality control measurement data acquisition requirements. Jeff, I'm going to hand the Zoom floor over to you.
Okay. Well, thanks very much, Elizabeth. I appreciate that. I'd like to get started here. Presentation. Again, remember to use the chat function to ask any questions during the process of this, and we'll get to them at the end. So during today's presentation, I will review traditional approaches to measurement, data collection in support of the Internet of Things, Industry 4.0, and the efficiencies gained from those technologies. I will talk about advantages of advanced wireless data collection, because it's one of the better ways to do this. Automated, it's fast, easy to use, it's scalable, has high data security, and in some cases, unrestricted distances of transmission. It also is compatible with leading wireless and electronic digital precision tools and gauges. And finally, we'll take a look at some actual use cases of these technologies in use. So let's dive in. The Internet of Things, or IoT, and in a broader sense, the fourth industrial revolution. Industry 4.0 is a new paradigm in manufacturing today, affecting the way manufacturers are operating or planning to operate, improving OEE, which is overall equipment effectiveness. And it's a new key to IoT requirements. Optimizing this OEE necessitates accurate, up-to-date data across the entire organization, including measurement and test data collected for quality labs and directly from the manufacturing floor. Increasing the speed and volume and accuracy of this measurement data is critical. It provides insight to improving efficiency and consistency of manufactured parts, which is most important for all of us manufacturers. In terms of acquiring and collecting information, for quality control purposes, the clearest path to these advantages comes from wireless and mobile retrieval technologies. People are on the factory floor and so are machines, but being flexible in the collection of that data is absolutely paramount. Wireless data collection systems should be mobile, as well as robustly encrypted and secured, and be suitable for multiple needs, such as being able to send data to unrestricted distances and locations, and compatibility with all of your shop gauges. And we'll speak up to that point a little bit later. To ease of use, practical integration into your manufacturing operations. The best wireless data collection systems can dramatically increase productivity, remove the potential for errors in your data collection, provide complete documentation, electronic signing, and automate the data acquisition process. Systems should include all of these benefits, and I emphasize all of those, whether it's used by a single employee or across an entire company with an enterprise-wide quality control system. Systems that ask workers to manually track key measurements require extreme attention to detail, and that must be maintained hundreds of times during a single shift. And we'll see this later in one of our use cases with Roush Yates racing engines, all of which are unrealistic to consistently do when a human is involved. And that's also assuming that data is even being collected in the first place. Education is another issue. Employees may not have the background needed to fully understand and accurately collect or transcribe the data. Transposed digits, misplaced decimal points, shortcuts, and similar issues commonly occur in data collection. Most importantly, an employee may need to halt production just to capture and record those measurements, and that reduces the overall productivity. And by doing so manually, it flies in the face of the Internet of Things and high efficiency and OEE. Computer security in the modern age is a concern for simple and highly automated manufacturers alike. Unsecured networks are used to transmit data. They can provide inroads for hackers to gain a more general access to the company's infrastructure. When measurement data is transmitted without proper digital security measures, it is a possible security risk. With business growth and diversification necessitating more quality control processes, that may be spread out over one facility or multiple locations. And at best, if a data collection system is not scalable, setting up separate data collection process is time consuming, it's cumbersome, and may lead to confusion and inaccuracies or delayed communication. Worse, it may result in product rejections, failures, and possibly even legal implications for a failed product ultimately in the field. The sampling strategy simply will not provide the complete picture offered by 100% measurement of each component produced. And the argument to counter that would be that it's time consuming and it requires people and expense to support 100% measurement. However, it's common with traditional QC processes and may lead to an inability to predict and identify drifting production tolerances. Sample strategies don't work in that case. In addition, this strategy is not even an option for industries such as medical or military defense that require 100% part inspection, but also traceable documentation for each part. So clearly, every rejected part represents money, time, resources that are lost. Without full insight provided by 100% measurement, manufacturers do risk incurring additional expense as well as potentially harming relationships with customers. If a would-be rejected part made its way to a customer, especially one that restricts standards compliance, the results can have serious implications, if not catastrophic. So to prove out these assertions, a controlled experiment was conducted numerous times, which was a 100% inspection test. We measured the impact of wireless data collection versus traditional collection methods, paper and pen or hand keying into a computer. In this experiment, 500 parts were measured by a human operator, and we did 3 different humans that took the data. 3 measurements per part were taken at the time, and then the data was recorded in various methods shown here. The parts quality distribution was previously recorded and triple blind correlated before running the experiment. So we knew what we had for the distribution data. In addition, 3 known out of tolerance parts were added to the 500-piece sample to ensure that those failures were captured and became an easily recognizable signature of the distribution data. And that was to ensure that the operators did the right thing for the measurements. If they were not existent, then we knew that the measurement would fail, or the measurement of the distribution data would fail. So methods 1 and 2 shown here on the slide indicate time-consuming hand movements to pick up and put down the tool in order to record the data. Results can be uncertain due to measurement value changing while it's being inspected as well. but the slowest method, number 1, required 29 seconds per part. And we saw 62 data entry errors out of 500. And those of you in the quality circles know that's statistically significant. Method 2 was faster than method 1, but data was entered into wrong cells after they were hand keyed into a computer through its keyboard, and had to repeat the experiment numerous times just to get a best case result as a benchmark. So when you have to transition from measurement to recording the measurement, problems will happen. However, with a wireless data collection scheme where a button is on or adjacent to the tool, it's very fast. We saw that there were, rather than 29 hand motion elements, there are now 17, and a total of 6.6 seconds per part with 0 data entries. So we knew we had a good experiment set up after correlation and running it through multiple times, but we saw that in general, wireless data collection is nearly 5 times faster than any of the other methods. What's important to do before considering a data collection scheme in your factory or laboratory, it's good to ask a couple of important questions to assess your needs. And by answering this first question thoroughly, you will expose the cost of not collecting data. So if you take a look at what is the cost of scrap, and the downstream costs of rejects in your production line. And when we say downstream costs, that means what happens if a rejected part or an out of tolerance part wears too quickly because of tolerancing and causes the entire system to fail. We have many customers that are concerned about this, that if they're developing, let's say, earth moving equipment and it fails in a remote location of a forest, it's hard to do a repair out in the field among the mud and so on. So it's really important to look at the downstream cost of rejects. And that really tells you how important your customers will regard your product as a result of field failures. Another good question is, what is the cost of your quality program and what's it made of? Where and how is inspection of data occurring today? So if you're collecting data, you need to ask yourself, why are you collecting it, and who is it important to, and is it supporting the needs of the overall organization and the output quality of your assembled final product? Other things to take a look at is, how many tools do you need to support? Again, we're talking about 100% data collection, so it may be all of them, but some of them are used for spot checks. So not all tools have to be supported with some kind of data collection scheme. What are the distances involved? How do you intend to store the measurements? What kind of computers will be used? How far apart are work cells? What is your SPC application, and how will you integrate those tools and that data into your MRP system or ERP system? From the previous slide, the basic principle of advanced data collection systems is to enable you to acquire large amounts of measurement data without impeding production, and that's the important part. As the benefits of data collection prove themselves, companies often expand their systems and consider your options if you have to do that, or if you plan to do that, to try it in, say, 1 work cell and expand to 5. The system needs to be scalable, secure, and robust to take those measurements. The system should offer benefits through automation, ease of operation, streamlined scalability, robust data encryption or security, other security computer measures, protection, transmit data over the needed distances. Those all have to be included. The result is increased productivity, capturing any and all rejects and improving your data fidelity. Reduced data entry errors, and that gives you complete documentation and reliable data acquisition process. When employees have to repeatedly stop work to record a measurement, as we saw in the previous experiment, productivity is negatively impacted. Also, any manual data collection processes will introduce errors into the records database, with potential to perpetuate flaws going forward. With advanced data collection, the press of a button can transmit that measurement data, significantly saving a lot of time. For example, remember, it's at least 4 times faster to push a button than writing the data down on paper, rereading it at a later time, and then typing it into a spreadsheet. Also, an important thing to note, data losses or loses its context once it is time and spatially removed from the work environment. In other words, if you have too much time between the time it was taken and the time it gets entered into the database, mistakes can perpetuate without the transcriber even knowing what's happening. And that will then get into the permanent record for the production. And that's something to keep in mind, especially if you have to do traceability or use traceability for your data. Further, software that collects the data can also request measurements from the tool for, say, an example, indicators in a test jig with a part rotating for TIR, total indicator runout. Or on a hot extrusion line, using tramming indicators as a simple and cost-effective solution to process feedback. So for example, the software can request a measurement, say every 10 seconds, telling the line operator that the process is drifting. And you can see that on your data, or if you're plotting it. Features such as automatic time stamping provide critical context for each data point, which is required for traceability, again, and compliance to many quality control and production specifications. High data volumes is something that you need to expect because you're doing 100% data collection. So they need to be processed without delay, and even when the system's at full capacity, meaning many, many tools running at high speed. Because advanced data collection systems do feature ultra low latency networks, very high speed bit rates, and high speed connections. High fidelity system performance is needed for 100% inspection. So all technology aside, it's also helpful to remember that establishing any data collection process can be met with resistance on any level in an organization. For company management, there may be uncertainty that putting a new method in place will have tangible benefits, and that has to be proven out. So doing a cost calculation about the cost of your rejects and then the cost of the system, you'll find out that any one of your final products that fail in the field may justify the cost of this system if you can prevent that. IT departments will want to review the technology for security and compatibility with the computer platforms, and that has to be communicated to all people in the process. Operators even may be resistant to change in using tools with push buttons on it to collect the data for accountability reasons, quality reasons, and many others. To offset those concerns, Starrett had made ease of use and high priority so that operators can quickly feel confident in the data collection process, and it's optimized in a short period of time. So we can get started right away with what seems to be a complex system, but it's actually quite seamless when it's fully deployed. For example, for ultra portability, the ease of operation extends to a mobile application that could run on say an Android or an iOS phone. And it's an excellent choice for many of the use cases we see, eliminating the need to lug a computer into the field or into a messy remote application, say on the top of a windmill or out in a forest measuring tree diameters, which we have customers doing that every day with DataSure. This technology all operates on the latest wireless shortwave radio frequencies. They interconnect with cell phones, computers, wireless electronic devices, and enables much faster speed and greater bandwidth, longer range for higher data throughput. The use case that's shown here in this example slide, it has a portable use case allowing the mobile application that's running on the phone, picture up there, to record all the measurements. It also allows the user to selectively prune the data log list if there's one that's out of tolerance or was measured incorrectly, or the button was pushed accidentally. They can be removed from the data log list. You can also perform arithmetic functions to those tools measurements in real time and provide simple SPC results for each run of data. So it's a very powerful application that you can take into the field with a multitude of tools, whether they have embedded radios or backpacks running on this mobile device known as Starrett, the Starrett mobile application. No extra hardware is needed, no PC, no gateway. A new network topology structure can be configured to many simple or complex use cases or situations, including distributed remote gateways for remote locations within a factory. The modular structure of advanced data collection systems make it simple to scale up or down. A QC solution could be implemented without having to acquire a new data collection system. So if you want to expand, rather than building a whole new system in your factory, you can just add on components and expand as your needs evolve. Data is transmitted from the gauges that have either built-in radio transmitters, like Starrett's new W series line of micrometers, calipers, indicators, or externally mounted end nodes or backpacks. They connect to a gateway and can run and talk to either a mobile application or iPhone or Android phone, or if you prefer, a Windows-based computer running on your company network, either a laptop, desktop, thin client PCs, or servers even. And to further extend into the far reaches of large factory floors, we have components that are called the repeater and bridge that connect to the system, and they dramatically expand the range of the system from hundreds of feet to, if you need it, miles in distance. An interesting side note, these bridge remote repeater components can optionally connect to PLCs and other high-speed serial automation equipment for real-time data collection for remote machine monitoring, or real-time data collection from those systems in their native communication languages, if you will. Those components can be independently operated separately from the DataSure or the Starrett data collection system, further expanding your system's flexibility using all similar components. For wireless measurement, these measurement tools here show an example of some of our primary tools that we manufacture today and are available today. Include embedded radios, making them compact and easy to use for data collection. One thing that many wireless data collection systems cannot do is be compatible with all leading electronic digital gauges, such as Starrett or Mitutoyo or Silvac or Fowler, Bowers, CDI, and so on. Many data collection systems that are provided today force the user to only exclusively work with their own tools. And that can be a problem if you have more than one brand of tool on your shop floor. And my guess is you do. On the other hand, most companies cannot retool their entire factory for one brand of tools, and we recognize this. And this DataSure 4.0 system recognizes this by being designed to allow other manufacturers' tools to work with this system. Further, having different brands of data collection systems can create compatibility and learning issues on the production floor. So having different incompatible systems in your shop adds more security holes in your operations, as I pointed out earlier in a different slide. Backpack radios are the means in which competitor tools, if you will, or other non-Starrett brand tools will work with the DataSure system. Silvac and Bowers tools, some Fowler tools will work directly with our system as well that have embedded radios. But if you have a tool with an SPC output or have formerly used a wired data collection scheme, though we have backpack radios that plug into that same socket on the tool and will allow you to adapt your existing tool investment with 100% wireless data collection system like DataSure 4.0. This reduces your cost of ownership and avoids you exclusively using the one brand of tool in your shop. Of course, we prefer you to buy our tools, but in the end, the backpack radios are unobtrusive and easily attached to whatever metrology solution you choose to attach to it. It is a fact that applications for data collection are incredibly diverse. Advanced data collection systems are adaptable to nearly every use case, with examples ranging from aerospace, automotive, agricultural, aquaculture, to 100% measurement of all parts and components in highly regulated industries such as defense, transportation, medical, energy generation, and more. In your application, the data collection process has a beginning and eventually evolves to include more tools and greater distances. And that system has to be flexible enough to be able to adapt to that and include all the tools that you intend to use. Benefits become more compelling as it grows beyond the reach of your existing wire lengths or systems that you already have deployed. Advanced data collection systems are designed to dependably and accurately acquire measurement data in an extensive range of applications, from just one or a few measuring tools transmitting over short distances to large deployments that have dozens of tools, hundreds of yards apart in a large factory, say in an automotive manufacturing line. The systems must accommodate very long distances, and the application requirements increase as your data collection requirements evolve and grow. So we're going to take a look at some of the network topologies or use case topologies of how these might go together. These components might work in your factory. For the majority of the applications we see, say about 50%, typical portable deployments are found mostly in field use or small contained lab environments. A mobile tablet or phone can serve well as a handy digital readout for when or where a measuring tool is held over your head or the tool's display is obscured in some way. The data can be shared by email or text by way of the mobile application. In its simplest form, this portable scheme shown here on the slide features an application running on that mobile device. Straightforward portable setup can have one Starrett tool measuring with an embedded radio transmitting data up to 30 feet to the mobile device. And just a word on that, the distance is limited primarily by the phone, not the tool in many cases. Or depending on the mobile device, this portable scheme may have 5 to 8 measuring tools in the application. And they all connect to this mobile app and can be used conveniently for collection and later transmission to your SPC database. When a user chooses to use a laptop, you can easily transmit measurement data from one or more measuring tools or tools with a backpack. Either of these schemes, with or without a backpack, can talk to then a computer, and that's what we'll take a look at next. This, I would say, is the majority of the applications we do see. It's where we have transmission distances to 200 feet, where we have tools, usually under 20 tools. But this is mostly what we see in the field today, but it's not limited to this. So you could have a computer or a laptop running a data collection system. That data SPC processing application could possibly be connected to another computer somewhere else in the factory, or it could be a served application or a web-based application. 20 tools are on the shop floor, and they're measuring or sending their measurement data to that computer up to 200 feet away. This deployment uses one USB gateway in the Starrett scheme, and it's included when you buy a basic system. The tools with embedded radios transmit up to 30 to 40 feet, and tools with backpack radios can transmit from 0 to 200 plus feet in your shop application. In a larger deployment, called here the large factory scheme, 20 measurement tools can use what we're calling a bridge and remote gateway. And that expands the total data transmission range from hundreds of feet or yards to thousands of feet. And that then puts the gateway closer to where the work is. Another interesting thing to note is that for every remote gateway that's added, you expand the capacity of the system by 20 tools. That's what we're calling here an enterprise scheme. And the distance now can be extended from hundreds of feet to over a mile. For a variety of reasons, we don't recommend multiple mile distances with your radios, but if you need it, it's there, the power is there. By using remote gateways, bridges, and perhaps even adding a repeater to get around large obstructions like mountains and other buildings, over 100 measurement tools can be incorporated. An important thing to note, as I said before, each remote gateway can be located in a manufacturing cell and support a maximum of 20 tools per remote gateway. If that's not enough, we can cover even greater distances by just changing out the antenna on the radio, which is referred to a Yagi long-range antenna, and can be incorporated for each component in this scheme, extending the range from miles to many miles if that's necessary. One of the real popular topics among computer and radio technologists these days is data security. And it's important for all manufacturers and businesses, including government operations. And while your measurement data by itself might not be particularly valuable to hackers or cyber criminals, they still will attempt to spoof your network that's transmitting this data and try to gain access to a company's larger digital infrastructure. In the case of Starrett, we've architected our system to be relatively immune to these kinds of attacks, and we stay abreast of all of the news that researchers are finding for vulnerabilities in various technologies, and we upgrade the system software on a regular basis. So it's not a one and done solution, but continues to evolve and improve. As I said before, the additional components of the system, remote gateways, bridges, repeaters, they're leveraged to offer an efficient, reliable data transmission framework. System structures can involve as few components as just a backpack on a tool and a mobile phone to collect data, or you could have more elaborate solution that uses bridges and gateways and repeaters to extend the transmission range and the number of tools that you can support natively. We've just covered some of the salient elements of what is necessary to have in a robust radio network. So here's a quick summary of what an overall system can look like. Data collection system first uses a wireless network to gather information from multiple measuring tools. And wireless, if it isn't obvious yet, it's important not only for ease of use, but wires can have a tendency to get tangled around operations, spinning lathes, chucks on machining centers, and are considered a safety hazard that needs to be watched carefully. So wireless gets rid of those problems. Secondly, the network relies on the tool's embedded technologies to gather the data and send it back to a PC or a personal computer or a mobile phone. Third aspect is that the system also sends signals out to the network components to verify transmissions or request data. This is where the computer or the mobile app can ask for measurements from the tool if the tool is in a fixture and you want to get measurements from indicator 1, 4, and 7, for example. Hardware components of the system, as described here so far, is either a USB gateway or a bridge and remote gateway together. And then you have the end nodes, which are either the tool itself or a tool with a radio backpack. The end node or backpack radio is it's a transmitter receiver that gets attached to a measuring tool through its SPC port. The smaller USB gateway, as mentioned earlier, is a radio transmitter receiver, and it's attached to the PC in one of its USB ports. A very simple, small memory stick size type device. Remote gateway, however, is a critical component needed to expand the range and number of tools it supports in the system. It's nearly the same as the USB gateway, but it extends the communication range from the PC. In this case, you need a bridge that connects to the PC, and you need a remote gateway that connects to the tools. That remote gateway in turn has the same range to the tools as in the other examples, either 30 or 200 feet, but now can be located extremely far away from the personal computer. Regardless of the system architecture put in place or that you need for your use case, the result is a dependable, accurate, fast solution that's scalable for gathering your measurement data. This is a picture here of our W798, which is our new wireless caliper. It comes in 6, 8, 12-inch sizes. It's IP67 level protected, so it means it's waterproof. You can immerse it in water or coolant, and it integrates seamlessly with major SPC software programs. We're also seeing now that the Internet of Things and Industry 4.0 is beginning to expand a lot more in the US. We're seeing more MRP and ERP integrations from SPC applications. So data coming from tools into data processing, going into material resource planning and enterprise resource planning applications for end-to-end integration from part to purchasing applications. So now I'd like to take a look at a short video of the data collection system and be done with me talking for a brief period. And hopefully this will come across, and enjoy.
Starrett DataSure 4.0 data collection system allows your electronic precision hand tools to securely transfer measurements wherever you need them to go. DataSure 4.0 works with Starrett and non-Starrett tools alike, making it the most flexible and comprehensive data collection system available. This system allows for instant wireless transfer of measurements directly from the tool to your computer, tablet, or mobile device. Starrett DataSure 4.0 and wireless tools eliminate the need for a written log of measurements, saving time and drastically decreasing the risk of operator error. Setup and execution is easy. For small-scale deployments, the only components needed are an electronic hand tool and a free mobile app. DataSure 4.0 is a highly scalable system. It is capable of transferring data regardless of the distance. The system's versatility makes it ideal for any environment, from small applications to large-scale operations. As your quality program expands, system components and electronic tools can be seamlessly added. The number of tools that can be added to the system is virtually unlimited. DataSure 4.0 is compatible with non-Starrett tools, so you gain all functionality without the need to replace your investment, a unique feature available only from Starrett. The enhanced capabilities of DataSure 4.0 are available at a competitively low price. Our factory-trained distributors and sales representatives are supported by our in-house technical team, so you'll always get the help you need. DataSure 4.0 is a highly customizable wireless data collection system that will enable you to increase your efficiency, accuracy, and productivity. The quality of your data is important. Improve your data integrity with DataSure 4.0. Contact your Starrett representative or a Starrett distributor to learn more about DataSure 4.0.
All right, and we're back. So let's take a quick look at the technical capabilities. We have transmission distances of 30 feet for tools with embedded radios. Distances for tools with backpacks is 200 feet. Remote gateways will expand the number of measuring tools and support additional tools in increments of 20 per remote gateway, up to 65,000. Now that's an awful lot, but a practical limit is typically under 200, after which you can add another computer and another instantiation of the DataSure server software. End node radios can store up to 10 measurements on the tool itself, whether it's a backpack, whether it's a competitor tool, or tools with radios that are embedded. They'll be stored in the tool if the system goes down for some reason or it's busy with other tasks. We've seen it happen where a forklift drives over a power cable and disconnects a laptop. Anything can happen. So we decided to put some on-tool storage capability. Inside the server software, we support up to 20 virtual multiplexers, which is hard to visualize here just in words in this short presentation. But what it does is it takes all of the tool data and funnels them through a serial COM port that will then connect to your SPC application or MRP and MRP system. Further, you can remotely monitor the network of tools that you have from yet a separate computer over your company Ethernet, which is known as our DataSure remote client software, and it's provided as part of the main server software installation, and that's free with any purchase of a gateway. We also offer a range of optional antennas that can be used for a wide range of applications and use cases. Now we're going to take a a look at one of our active customers who allowed us to share their use case with you, and that's Roush Yates Racing Engines. Roush Yates Engines, RYE, they're from Mooresville, North Carolina. It's the exclusive engine builder for Ford Performance Motorsport Company, which is used in the top levels of NASCAR racing. Roush Yates uses extensive CNC precision manufacturing, as you can imagine, for all their engines. They also perform discrete parts manufacturing for automotive, aerospace, medical, defense, and high-tech industries. Roush Yates has deployed the Starrett DataSure 4.0 wireless measurement data collection system in one of its two 80,000 square foot machining facilities. Each day, several thousand precision measurements are recorded here. These data need to be tracked and documented to ensure their high performance and quality control requirements. The current application at Roush Yates is a use case encompassing multiple digital indicators, as you can see in the picture here, attached to an engine fixture where total indicator runout data are captured for valve spring compression. And these are documented, the data is documented automatically and then transmitted over 200 feet to the opposite end of the production plant, which is where the quality lab is located. Prior to adding DataSure 4.0 to their operations, Roush Yates said to make individual measurements on each tool and each stroke of the engine, entering each value by hand on paper, and then re-entering the values into a spreadsheet on a computer. As we discussed earlier, that's prone to error. It's labor intensive too, and that makes it very expensive and time consuming. So it also introduced the potential for scrap and rework again for uncaptured mistakes just from the data entry aspect. And it offered no end-to-end confirmation of the acquired data fidelity. So it was a problem for them because Roush Yates adamantly confirms that engine failure is not acceptable in racing. So it's necessary for them to collect every critical dimension of each engine, regardless of the cost and time and that impact. DataSure solved this significant time and cost penalty for their precision operations. In the past 8 months since DataSure was implemented, Roush Yates analyzed its new process and calculated that 8 to 10 seconds were shaved off of every measurement that was taken, saving over 7 hours of inspection labor each day. So think about that. That's a whole person just collecting data, or at least in measurable savings, and eliminated all incorrect transcription of the measurement data. And from Todd English, he said that we saved 8 to 10 seconds on every measurement taken and have eliminated incorrect documentation. So that's a direct quote from Roush Yates. We've seen other applications too for some of our beta sites. Here's one where it's involving wing and spar, wing spar milling. At an aircraft manufacturer, there's 13 milling stations. Each milling station is a humongous 90 feet long, and it involved a gateway and used two tools with end nodes on the backpack. Overhead cranes were radio controlled and had strict concerns over radio frequency interference. In their application, data was being taken by hand, but then entered by from the paper to a PC into Infinity QS, which would be the SPC application of choice there. So the milling machine stops, the operator has to get out of the cab, take measurements with 2 micrometers, write down that data, go back into the cab, key it into the PC. In a power generation example, we have on-site machining of hydro turbines, and this was a pretty scary application where you had a machinist sitting on the boring tool while the housing to be machined was spinning around him or her, causing vertigo. They still needed the data so that they knew they were machining to tolerance. So we ended up using a wireless data collection tool on a boring bar, measuring as the machining tool was carving away the inside diameter, and then sent the data to an SPC application, keeping the machinist free from harm. Oil well pipeline example. This was tapered threading. They had problems with demagnetizing their pipes for borescope thickness measurements, and they were expecting the wireless to be disabled, but they were not. Rather, they saw some problems with their computer monitors, and were expecting that wireless data transmission would not work, but it ended up doing just a fine job for them. They have to be very careful about their tolerances, because half a mile down into an oil well, or miles into an oil well, is not a place where you want to have a leak or a problem with your pipeline. Starrett has more than 25% or 25 years of experience in data collection systems of all types, and over 140 years as a leading global manufacturer of precision measuring tools, gauges, metrology systems, and more. The deep level of experience combined with expertise and quality control is unmatched. For DataSure 4.0 and all of our tools, we offer free, dedicated service and support available directly from Starrett technicians and developers like myself, simply by contacting Starrett USA headquarters in Athol, Massachusetts. I appreciate all of you taking the time out of your busy schedules to attend this webinar, and would be glad to answer any of your questions at this time.
Jeff, thanks for a wonderful presentation. And we do have time for some questions that have come in. Sam is asking, he says that my current electronic gauge is not wireless. How can I integrate them into the wireless measurement data collection system?
Well, depending on your SPC applications, it can allow manual entry of measurement. If the tool is electronic and has a data output, you can plug on a radio backpack. But if it does not have an SPC output, that may be a problem. You would have to replace the tool with either an embedded radio tool, or find another one with an SPC output.
Great. And I see a question from Jack, says, how long can I expect it to take to learn to use the DataSure 4.0 wireless data collection?
Oh, that's a great question. It's usually under an hour, but to learn how to use it, to press a button, I think it's maybe a few seconds.
So anyone can learn how to use it, just a few minutes.
Yes, yes.
Great. And let me see. Another question here for you. What advice can you offer for reluctant users to change their ways on how they collect QC data?
Well, depending on the behavior, for sure, needs a different response. But what we see a lot is that manufacturers are bringing in a lot of new talent that don't have any manufacturing or metrology experience at all. Your best bet is to go through a training program, through a vocational technical school. Companies like Snap-on and NC3 programs have training for those operators. Metrology is a very precise hand motion activity, and it requires knowledge of the tools, how parts are measured, what squareness is, and so on. So if you can be setting up a training program from some of your best machinists, they're probably the best trainers too on how to and how not to measure and collect data from manufacturing parts. Training is the answer.
And Larry here has a question. He wants to know if you have an ROI calculator to use to evaluate using DataSure 4.0 wireless data collection.
Great question, Larry. We actually do have an ROI calculator that basically considers the value of scrap and downstream rejects in your operation. It includes shift differentials of employees and how many people are handling tools and so on, and then add that into the cost of, or subtract that from the cost of what a system would come out to be. And usually we find that most applications, even in their simplest form, pay off within 3 months.
And
But yes, we have that. You can find that information through our sales and marketing departments.
So they can find that online.
They should be able to, yeah.
Great. And I see another question came in from Sam. Where do I begin to implement DataSure 4.0 wireless collection?
What was that last word, Elizabeth?
Where do I begin to implement the DataSure 4.0 wireless data collection? Where do they start? Or I guess, how should they start by implementing it?
Yeah, usually it's in a QA lab where they have the best capabilities and understand the importance of statistically significant data. They have standards, they have temperature control. That's a good place to start, using your quality professionals to assess the gauges, the measurement techniques, and then further expand into a single machining cell, then to multiple machining cells.
Great. Well, I don't see any more questions coming in, so I think that will wrap it up. But Jeff, again, thank you for a wonderful presentation, and I'd like to thank everyone for attending.
Okay, it's my pleasure. Thanks so much.
Have a great afternoon.
Thank you.